Hey guys, welcome back to our channel Get Play Soon. In this video, let us see how to find factorial using recursion. Now let's understand what is factorial. Factorial is a product of an integer and all the positive integers below it. So, in simple words, if I have to say you, the factorial of a number is obtained by multiplying the given number by all the previous whole numbers less than it till 1. Okay. Now factorial is represented using n factorial, that is n exclamatory mark as shown in the slide. Now we have two formulas for finding factorial. The first formula directly follows from the definition we spoke about. So n factorial is equals to n into n minus 1 factorial. The expansion of the first formula is the second formula where it states that the factorial of any number is given number multiplied by the factorial of the previous numbers. So n into n minus 1 into n minus 2 till you reach 1. In short, you can write n into n minus 1 factorial. Now, for example, let's take 5 factorial. To find 5 factorial, you have to multiply 5 into 4 into 3 into 2 into 1. That is 120. Now, you can see in the table here. Always remember the value of 0 factorial and 1 factorial is 1. Okay. Other than that, you can calculate 2, 3, 4, 5 factorials using the formula n into n minus 1 into n minus 2 till you reach 1. You keep on multiplying the previous values. Now, let's see how to achieve this in programming. Now, for example, factorial 5. To find factorial 5 by the given formula n into n minus 1 factorial, 5 into 4 factorial you have to find. Now, how to find 4 factorial? To find 4 factorial, you have to do 4 into factorial 3. To find factorial 3, you need 3 into factorial 2. To find factorial 2, you need 2 into factorial 1. And factorial 1 is 1. Now let's see how to calculate. Now you have all these things, right? To calculate 5 into factorial 4, you are supposed to calculate the 4, 3, 2, 1's factorial. So let's start calculating. Now in the last step, factorial 1 value you know, that is 1. So 2 into factorial 1 is 2. So getting to the next step, 3 into factorial 2 is 6. 6 into 4, that is 24. 4 into factorial 3 is 24. Now 4 factorial value is 24. So 5 into factorial 4, 5 into 24 is equals to 120. Now this is how you find the value of 5 factorial. 5 factorial is 5 into factorial 4. Now we obtain the value of factorial 4 by doing all the 3 steps, that is 24. 5 into 24 is equals to 120. Now let's see how to do this in code. Here in the factorial method, you can see it is a recursive function. So inside recursive function, we are just giving n as the input, where n is the number. For that, you need to find the factorial. In the if-else statement, you can see if it checks if n is equal to 0 or 1. If so, it returns 1 because I already told you the factorial of 0 and 1 is 1. Or else, it calculates a factorial by multiplying n with factorial of n minus 1. This is the formula which we spoke about. So what is happening here? Always remember in recursion we have two cases. One is base case and the recursive case. In the recursive case, what happens is you call the function again. So in the else function here, n into factorial of n minus 1, you're calling the factorial function again. So this is a recursive function. I hope you understand, as it is very simple. Just we are implementing the formula here. In the main function, we are giving the number 5. We are putting the result. In the result variable, we are passing the number into factorial function and we are storing it. Once we get the result, we will print it. As simple as that. Now let's speak about time and space complexity. The time complexity is expressed as O of n, where n is input for which we are calculating factorial, because in the recursive function, the function is called n times, each time reducing the input by 1 until it reaches 0. So for example, if you are calculating for 5, you are running the factorial function 5 times. Therefore, time complexity is O of n. Now speaking about space complexity. Space complexity is also O of n because each recursive call to factorial function adds a new stack frame to the call stack. So we are consuming extra memory. We are adding the memory whenever we call to the stack. That's why the time complexity and space complexity is O of n. I hope you understand the video. Thank you so much for watching till the end. Please like and share this video. If you have any doubt, feel free to ask in the comment section, and please subscribe to Get Play Soon. Thank you so much.